Question 15d. The probability that a person chosen at random has red hair is 0.02. Part 1. Two people are chosen at random. What is the probability that at least one has red hair? Applying the law of complements, the probability that at least one person chosen has red hair is equal to 1 minus the probability that none chosen have red hair. And that equals 1 minus 0.98 squared, which equals 0.0396. Now this situation can be modelled using a probability tree. 0.98 squared comes from this branch of the probability tree. And that represents the complement of at least one has red hair. So R bar times R bar, that's 0.98 times 0.98, and that's 0.98 squared. And if we subtract that from 1, we get the probability that one of these three outcomes could result. So that's at least one person has red hair. Part 2. What is the smallest number of people that can be chosen at random so that the probability that at least one has red hair is greater than 0.4? The probability that at least one person chosen has red hair being greater than 0.4 is equivalent to the probability that no one chosen has red hair being less than 0.6, since they are complementary events. So we're going to solve for n the inequality 0.98 to the power of n less than 0.6. Taking the natural logarithm of both sides, we have ln of 0.98 to the power of n less than ln of 0.6. Now applying one of the logarithm laws to the left-hand side, so the n comes out to the front, we have n times ln of 0.98 less than ln of 0.6. Now note that ln of 0.98 is a negative number. So when we divide both sides of the inequality by ln of 0.98, we need to switch the inequality sign around. So n is greater than ln of 0.6 divided by ln of 0.98. We have n is greater than 25.285 and so on. But n is an integer as that represents the number of people chosen. Hence, the smallest number of people chosen is 26, since 26 is the smallest integer greater than 25.285.